Good morning. We are going to finish up our lesson on exponential equations with logs. So this is part 2. And I wanted to begin this lesson with a quick summary of what we finished up covering in our last lesson, because we're going to use that as a springboard for finishing up and putting it all together. So in the last lesson, we basically covered that there are times when you can't solve an exponential by writing each side as a power of the same base. So for example, if you had the equation 3 to the x equals 10, there's no way that you can write 10 as a power of 3 and then set the exponents equal. Now we can figure out stuff about the value of x. We know that x has to be greater than 2 because 3 squared would give you 9, which is going to fall a little bit short. We know that x has to be less than 3 because 3 to the third power would give you 27, which is too big. And that x is closer to the 2 than it is to the 3. But we need another way to go about solving that without having to go through this long guess and check process. So the first step in that is to take your exponential and change it to a logarithm. And so we looked at this. We looked at b to the e power is equal to n. Now notice that there's no number or expression multiplying the b, and there's nothing being added or subtracted. This is just something, a base raised to an exponent is equal to some number or expression. And that can be written as a logarithm as log base b of n is equal to e. And again, note how I say that. How we say things is important. Log base b of n. It is not log times n. If you're saying that in your head or you're allowing yourself to say it out loud, that is wrong, and you need to stop saying it wrong, because if you say it wrong, you'll eventually write it wrong or you'll do something wrong in your math work. So it's log base b of n. It's an operation that we're performing on the n. So that converts our exponent over to a log. Now the problem with this is that while a growing number of calculators will evaluate logs of varying bases, a lot of them don't. And if you're not planning to take a lot more math classes, then you might not want to invest in a calculator that's going to do that, because the more you want your calculator to do, the more you have to pay for it. And if this is the last math class that you're going to take in your high school career, maybe the last math class ever, or the last math class for 10 or 20 years, you don't want to spend that money on a calculator. So you might just have a more basic calculator, and more basic calculators will only evaluate two types of logs. They'll evaluate a common log, which is log base 10. Okay, and if you don't see a number written as the base, the assumed number is a 10. They'll also evaluate something called a natural log, which is represented by an ln, and we will actually cover that in the next lesson. We'll go through what an ln is. But you can't do log base 2 or log base 3 or 5 or 9 or whatever other base you might have. And so we need to use something called the change of base formula, which is this. If you have log base b of some number a, that is equal to the log of a. I call that the argument. That's called the argument or the attic, okay, the top number, divided by the log of the base, or the basement. And you can just remember the attic is up above your house and your basement is down below your house. And you can even see the position in the log. With the base is written a little bit lower. So that can help you remember the change of base formula. Now, one of the things that was covered in the last class, and I posted the video, I went and found the video. I had recorded a video last year, but it was unlisted because last spring what I did with my YouTube videos was I would post the link to them, and only people who had the link could access the video. So I went and I made that video public, and it's a tutorial on the different types of calculators that you might have and how those calculators can be used to evaluate logs of different bases. So hopefully you were able to look at that and find a calculator that looked like yours. And so you can evaluate them. So now we want to put this all together. We want to be able to solve logarithmic exponential equations using the logs. So I'm going to, as per usual, I'm going to give you the steps. I'm going to color code them. We're going to work through an example. I'm going to do 3 examples, and then you will be set loose to do some practice work, which you will turn in for me. So let's go ahead and set this up. We're going to have the steps over here on the left. And our example is going to be 4 to the n minus 3 plus 10 is equal to 15. And as you're copying that down, I want you to notice that the minus 3 is in the exponent and the plus 10 is not in the exponent. These things do matter. Okay, they do matter. They are important. They make a difference in your order of operations. That the minus 3 is trapped up there in the exponent. It's grouped together with the exponent, and the plus 10 is not in the exponent, which means you're free to do stuff with that. So for our first step, we'll do our first step in purple. The first step is to isolate the exponential. Okay, and we've done this before. So when we've been solving other types of equations, you'll notice that we often isolate the aspect of the equation that we're trying to solve for. So back when we did absolute value equations, the first step to solving an absolute value equation was to isolate the absolute value. When we were doing square roots, the first step to solving a square root equation is to isolate the radical. You want to isolate that part because you need to undo it, and it simplifies your process there. For us, we need to isolate that exponential because before we change it to a logarithm, we need to have just the base raised to the exponent equals a number or expression. You can't have a plus 10. You can't have a number multiplying it. You can't have other stuff over there because it's not incorporated into our formula there. So for this, to isolate the exponential, we need to subtract 10 from both sides. So we'll have 4 to the n minus 3 is equal to 5. And now your exponent is isolated. Step 2, we'll do this in blue. Change your exponential to a logarithm. And that is a skill that we covered last class that employs that this right here where you're going to write log base b of n equal to e. And hopefully you got some practice with that looking at the homework. So this would be log base 4 of 5 is equal to the exponent, which is n minus 3. Remember that it doesn't change the principal just because you have like a yuckier looking exponent there. So just because the exponent is an n minus 3, it doesn't change the principal, which is why it's so important that you learn the principles and not like shortcuts and not methods. Like you want to learn the overall principle there. Now changing over to green. Okay, then you're going to evaluate the log. Now, there are some versions of these problems where you actually would not evaluate the log. Those are problems where you might be asked for the exact answer, because the moment you evaluate the log is when you end up with a decimal and you end up rounding the decimal, which means that you have an approximation, not an exact answer. So if you are asked for an exact answer, you actually don't go through the evaluation process. You just skip over that and you move on with the rest of the equation. It's actually easier to do, but students do sometimes have a hard time getting their head around what the algebra looks like, but it actually involves fewer steps. We're going to look at exact answers in the next lesson, which is on the natural logs. So we evaluate the log. Now for some of you, this is like the step that's different depending on your calculator, but for a lot of you, that means using the change of base formula. So you're going to do log of 5 divided by log of 4, and then you'll throw that into your calculator, which will give you 1.1610. Always pay attention to the directions for your rounding there. So yeah, we have a 1.1610 is equal to n minus 3. And then our last step is solve for the variable. And so in this case, the variable is n. We have n minus 3. We know we undo subtracting 3 by adding 3. And I would encourage you to actually use the calculator for this, especially with adding. When you end up with some negatives, there are a couple of things that students will tend to do that will that you think it's going to be obvious when you do like the adding or subtracting with the negative, and it's not. And so you should have the 1.1610 sitting on your calculator. It should be sitting there on the display. Just go ahead and keep that on there and hit +3. Don't delete it off of there. It's really simple to do. And this ends up being 4.1610 is equal to n. And we are done. So I hope that your reaction to that is, gee, that was easy, like easy peasy. So I'm going to work through just 2 more examples. We're going to look at just a couple of different things that you might see, and then you will be free to work on your classwork. So let's take a look at the next one. The next one is 5 to the 3p is equal to 15. And our steps, of course, are isolate the exponential. And I'll start abbreviating that. So the way this should work is you should have those steps written down. You should have this nice example problem. And if you can do it with the colors, awesome. If you can't, that's fine too. I just try to teach with the different colors. And you go back to those steps, and then you look at the problem that you have, and you say, okay, how do I apply that step? And the example problem should guide you. It should give you an idea. Well, what does it mean to isolate the exponential? Oh, look what Ms. Taylor was doing. That means you're going to subtract, the 10 from both sides, and my final answer should look like this. So when you look at this, you should recognize that the exponential is already isolated. So you don't need to do that first step. Next step, which was in blue, which is change to a log. So this would be log base 5 of 15 is equal to 3p. And again, you go back to your notes, you go back to that example, you say, oh, that's what it means to change to a log. Next step, evaluate the log. And again, the example problem should be helping you there. So evaluate the log means that you're going to take the log that you have over here, log base 4 of 5, and you're going to use the change of base formula, and then your goal is to end up with a decimal. Now, one mistake that students sometimes make is they accidentally copy the numbers from the example problem instead of looking at the problem that they're on. So just be careful about doing that. So this would be the log of the attic, which in this case is 15, divided by the log of the basement. Keep the 3p over there until you're ready to deal with it. And then we dump that in the calculator. And I did not change my color. I should have been using a green there. Look at that. Magically turned to green. Imagine that. So this is step 3. Evaluate the log. And again, notice I'm condensing the steps over here because you don't want to be writing them out all the time. Like you want to be getting more efficient at using them. Log 15 over log 5 is 1.6826 is equal to 3p. And then our last step, which was the red step, which is solve for the variable. And that's going to change depending on the individual problem. So here we're looking for p, that is 3 times p. You undo multiplication with division. That should be in kind of an automatic thought process for you. Like a lot of you don't even think about it. You see 3p and you automatically divide. You want to remember why you're dividing. Because that principle is what really matters there. And we end up with 0.5609 is our value for p. Okay, one more example. And this time I'm not going to write the steps off to the side because the goal is that the more you do the examples, the less you have to look back. So while the first several problems you do, you might have to have your notebook right in front of you and you're constantly looking back, like what were the steps? By the time you get to the 4th, the 5th, the 10th problem that you're solving, you actually know those steps and you don't need to keep going back to your notes. Except maybe if you see something that looks very different. So this one has 2 times 4 to the 2x minus 1 is equal to 6. Step number 1 is to isolate the exponential. Now this one is one that tends to cause a lot of mistakes, both for Algebra 2 and for my college algebra students. Like this is just a real sore spot. But the exponential here is the 4 to the 2x minus 1. That's the exponential. So the thing that doesn't belong there is the 2. Now, and that's 2 times the exponential. And so without a whole lot of prompting, if I were to ask you, how do you undo multiplication, you would say division. Now, a really common mistake that students will make there is they will multiply the 2 and the 4. Here's why that's not okay. So I'm actually going to put it over here to the side. Watch order of ops. The reason why that is not okay is because your order of operations. In your order of operations, you have please excuse my. Exponents come before multiplication. You have a 4 raised to an exponent of 2x minus 1. There. The 2 is not being raised to that exponent, just the 4. If you multiply them together to get 2 times 4 is 8 to the 2x minus 1, then you have like merged the 2 and the 4 together, and you are raising the 2 to that power as well when it was not raised to the 2. Now, there are some other things you could do with this. You could take the 4 and write it as 2 squared, and then deal with the distributing the squared through the 2x minus 1, and then you would have like bases and you could multiply them together. But that honestly is going to create a lot of extra work for you, so I would strongly discourage you from doing that. The first step in solving this is going to be to divide both sides by 2. So you get 4 to the 2x minus 1 is equal to 3. Next step is we will change it over to a logarithm. So log base 4 of 3 is equal to 2x minus 1. And now we need to get some kind of value for log base 4 of 3. So that's going to use the change of base, log 3 divided by log 4. And that decimal is 0.7925 is equal to 2x minus 1. And then our last step, which was our red step, is to solve. And so we've got 2x minus 1. We want to get the x by itself. So we'll add 1 to both sides to get 1.7925 is equal to 2x. And then divide both sides by 2. And I kind of ran out of space there a little bit, but we end up with x is equal to 0.8926, or 62. Sorry. That mistake, actually, what I just did there, I said it out loud. I said 26 instead of 62. That is called transposing the numbers. It's super, super common to do. You just like switch 2 of the digits around. So if you're ever getting like a wrong answer and you're pretty sure that your algebra is sound, check to see if you've done that, if you just switch the 2 digits around. It's more common for some students and for others. And if any of you have like dyslexia or something, you'll be more prone to doing that than others, but anybody can do it. And so that's our last example. So what you should have in your notes at this time is 3 examples of working these problems out. And what you are going to do for practice is, I will post this online somewhere, 4 problems that I'm going to have you work out and explain the solutions to them. Now, one of the problems that you're going to do is this problem right here, 8 to the x minus 4 equals 6.3. And I did say at the beginning of this lesson that you would be able to solve that and you would think that it was easy. So we will stop the lesson at this time and transition over to your practice work.